There we go. All right, let me repeat all that for the GoPro. Oh, no, I won't. I'm sorry. For our people at home. And I finally figured out how to upload things videos onto Canvas. So for the first time, you should be able to watch this from home. I hope. Okay, second, the ideal pulley. Ideal pulley. It is also massless. It is frictionless. And it, what's the other thing? It's massless, it's frictionless. I guess that's it, because massless also implies it has no rotational inertia. Rotational inertia. Which is kind of like mass. It's like inertia, but for rotating things. Okay, so massless and frictionless. So, for instance, if we take a look at the homework problem we did, we have a ideal pulley here. We have a mass hanging from the pulley, M2. We have a mass sitting on the table, M1, and they are connected. Oh, the most important thing about tension, and that is 0. T is the same at both ends. All right, this is the most important thing. This is the thing that's really, really important. T is the same at both ends. Okay. So that means that if let me draw the free body diagrams for M1 and M2. Okay, so for M1 and M2. So for M1, we've got gravity down, M1G. We've got our normal force up. We can put it opposite because, well, we're going in our X, Y directions. All right. We've got tension going this way, and we've got friction going this way. For M2, I've got gravity pulling it down, M2G, and I've got tension pulling up on it. And nothing else. Okay, so let's first write our vector equations. Okay. In this case, everything is just in the y direction, so we can say sum of Fy is equal to 0 is equal to, well, T is up minus M2G. All right. Well, this one, for this one, we have the sum of forces in the x equals 0. Sum of forces in the y direction is equal to 0. Positive, so that's T minus F. Okay. And in the vertical, it's N minus M1G. All right, so we have 3 equations and only one unknown, which means this is overdetermined. Yes?
So you used M1 and M2 as the mass, but then you also use them as like the name of the object. So is that a typical convention?
That's typical convention, yes. Yeah. So yeah, I'm identifying this as M as mass 1, object 1. Yeah, actually that would be a good thing for me to do. I would put M1 mass of object 1, object on table. Right? M2 is equal to mass hanging from string, mass of object hanging. All right. F is force of friction. And G, as usual, is 9.8 meters per second squared. So yeah, I'm sorry for not including this. You're right. I should include my explanation table here. And that's something that is also, I don't know if you'd call it traditional, but it's the thing that everybody does. Like if I'm writing a paper to be read, if I'm writing a report, okay, anytime you have an equation in a written document, you always define what your symbols are. You always define what goes into your equation. So this is, first of all, a good idea to help you keep your stuff organized. And B, this is something that if you ever go into, engineering or science, you need to, it is something that it will become a habit of identifying the things that are in your problem. Okay. So we've got an ideal string, an ideal frictionless pulley. Okay. And so we've got, like I said, we've got 3 equations and we've only got 1 unknown. Well, actually we've got 3 unknowns because we don't know what M1 and M2 is. Okay. So that actually means that we can get our 3rd unknown in terms of the other one. So now that we've got all this, we wanted to find mu, which is equal to F over N, magnitudes, by the way. And so we get F is the same as T, N is M1G, T is equal to M2G, that's over M1G, G goes away, and so that tells us that for this particular problem, and this is kind of a special problem because we have a force balance here. Okay, we have a unique value for our acceleration is 0. Okay, when our acceleration is 0, you can get things like our coefficient of friction depends only on the ratio of our masses. We could take this to the next level and say, okay, we're actually, this is moving with an acceleration of 1 meter per second squared. All right, that changes everything. Right? First of all, it's going to change our friction. It's going to be sliding friction instead of static friction. It won't change our value. It will change our value of T because if in this case, instead of some of our forces